Hello and welcome to the presentation KNX DALI Gateway Premium DGS X6451. My name is Jürgen Schilder from the company ABB BJE, and I work in the field of building automation, training and qualification. In the next 30 minutes, I will give you an overview of the powerful functions of the KNX DALI Gateway Premium with the new ETS application. These are the color temperature DT8 Tunable white with dim to warm and Humancentric Lighting, the color control DT8 RGB and HSV, sequences, load settings to avoid load peaks, operation duration, standby, switch off to save energy, and the enhancements in the ABB IBUS tool. I would like to start with an overview of our KNX devices. The product range this ranges from lighting, shutter control to heating, cooling, ventilation, security, energy management, user operation, and more. Here you can see a selection of some devices. But today we are going to put the focus on the DALI Gateway Premium with the new ETS Application 2.0. On this slide, you can see an overview of our DALI gateways and DALI light controllers. On the left side, the DALI Gateway basics with 1 or 2 outputs to connect up to 64 ballasts per output, standard ballast, and also emergency converters with the flexible combination of single or group control. In the middle, we have the DALI Gateway Premium, also with 1 and 2 channels. And this device supports also emergency light converters and has some functions like DT8 color temperature control. Some weeks ago, we launched a new ETS application version 2.0. And this version 2.0 offers more functions with extended functions like DTA, color control, RGB, HSV, sequencer, load shedding, and more. So if you have an existing installation with the DALI Gateway Premium with software version 2, you can still keep it like it is. Or if you want to use the new extended functions, then you can use the ETS app and convert the ETS version 1 application by using this app into the version 2, including the complete parameterization and the group addresses. So it's only a short step to convert the existing device into the version 2. On the right side, we have the DALI light controller as a DIN-rail device or also as a flush-mounted device for constant lighting control. So let's have a closer look on the DALI Gateway Premium DGS X. X means 1 or 2 outputs or channels, and 5 means is the hardware or is the device premium. So the device has 1 or 2 channels, and the following ballast can be operated on the DALI outputs. Normal ballast from the device type 0 or 6 for fluorescence lamps or LEDs. DALI self-contained emergency converter from the device type 1 of the type A, B, C, and D. This is also a new function in the new ETS application. Additionally, color control DALI ballast from the device type 8, like tunable white, RGB, and HSV. The DALI Gateway Premiums offers a wide range of functions, like the flexible combination of DALI groups or single control, the support of the ABB IBUS tool, and tunable white color control. These are the functions I would like to show you now step by step. Let's come to the tunable white color temperature control device type 8. What is it? Color temperature control means that it's possible to change the temperature of the light between warm and cold white by dimming between warm and cold or setting also values. For this one, we need special lamps and also special DALI drivers of the device type 8 tunable white. Like here on the right side, you can see such a tuple range of this color temperature light from warm white, about 2000 Kelvin, to cold white, 6000 or 6500 Kelvins. So not only the brightness of a light or the distribution in a room is important, no, for the quality is also the color temperature important. Because the color temperature has an effect and also promotes the well-being of a human. For example, when we have more warm light, this is more for relaxation, and cold white is more for activation. So the tunable white color temperature control, we talk about 3 ranges of the color temperature. So one is the warm light. So we have up to 3300 Kelvin. This is more for homely and comfortable. So this is like the temperature of a sunset or also sun rising. The middle range, the so-called neutral light range, is between 3,300 and 5,300 Kelvin. This is more for stimulating and inviting to make it, for example, also for working. And the range above 5,300 Kelvin is a so-called cold light range and is similar to the daylight and promotes also for concentration, because here we have a higher proportion of blue light. And on the right side, you can see a picture of a typical living room with tunable white spots here on the ceiling. The left picture is taken about 3,000 Kelvin, which gives more warm white, which is more comfortable. And on the right side, about 6,500 Kelvin. So you can see the same room with different color temperature, and here the difference. And on the bottom, you can see a typical tunable white device type 8 for color temperature ballast. The ballast has one DALI address, but on the output, you can see here the common, the plus, and one output here for warm white and for cold white. So then let's come to another function, the so-called dim to warm. But at first, let's have a look at a typical LEDs. So now when a LED is dimmed from 0 to 100%, the color temperature of a LED remains constant and does not change. But in some applications, the end user wants to have a function like a typical incandescence lamp, so so-called light bulb effect. And a typical incandescence lamps, there's a behavior when we dim up, the color temperature is now increasing to more cold white, and when we dim down, then it becomes more warm white, so decreasing of the color temperature. And by using the DALI gateway with the tunable white function and dim to warm, we can exactly simulate this principle of an incandescent lamp by using the LEDs. So this is a nice feature which we can activate per group or ballast. Then we have exactly the same behavior like incandescent lamps. You can see it on the right side. So we have on the left side a brightness of 30% and about 3,000 Kelvin. And when we dim now brighter to 90%, we have 6,500 Kelvin. These are the parameters, of course, we can set in the ETS. So this is a typical, or these are some typical applications of the dim to warm functions, like in a restaurant or at home in the living room or bedroom. So we have here maybe candles, or we want to have a fireplace, and then we want to dim darker. Then we would like to have also more warmer light. And on the right side, when we dim here brighter, dim up, then we have more cold light. So another function of tunable white is a so-called Humancentric Lighting, HCL. So when we have a look in a typical room without a window in a building, for example, and then we have artificial light source. And this artificial light source should have the same features like the sun outside. Like, for example, here in the morning, more warm light, and in the afternoon, more cold white with more proportional of cold white. So, and this light outside has also a very important effect on the human health and well-being. And by using this HCL principle, we can simulate, for example, exactly the sun outside a building in a room. Like we'll see it here on the next slide. We use the dim to warm function, the driver and the lamp. And by using the DALI gateway, we simulate the daylight outside the building in our room. So like in the morning, we have here warm light about 3,000 Kelvin, and in the afternoon up to 6,000 Kelvin. So for the human being, it's inside the room like he's really outside and gets here the different color temperature from the sun. Of course, this is a very, let me say, easy way to do it. There are, of course, more complex systems with HCL. Not only the color temperature changes, also, for example, the brightness and direction of the light and some more things. And this HCL, Human-Centric Lighting, is a very popular at the moment because it is used in a wide range of applications, like in educational institutes, in offices, to motivate the employees, or for healthcare facilities to avoid mood swings, depressions, and also in the industry to have an effect on the production output. Like here on the highest value of 6,000 Kelvins, the human being is more productive. And at the night, in a night shift, in a factory, for example, when we simulate exactly this curve, then we can also here motivate a human being to be more effective. So then let's come to another color function, the so-called RGB and HSV. There are two possibilities to create a color. So in principle, a color is made of the three primary colors, red, green, and blue. So by using this RGB color space, we can mix color of more than 60 million different colors. So we have like a cube here. We have a look here like a typical cube with the three axes, the red, the green, and the blue axis. And each of the axes, we have a value between 0 and 255 or 0 and 100%. And then we can mix here the color. Like, for example, when we have 100% red, 100% green, then we have here the color yellow. And so you can mix more than 60,000 million of colors by using this principle. Or here on the right side, we have a value of R80, green 200, and blue 130. Then maybe we have this little bit green here. So when we mix all three colors with 100%, and then we have theoretically the color white, like here in the middle. But today, it's more popular to have another LED, a so-called white LED. That's why we talk here about RGB W, and sometimes here the W is here in brackets or not. And on the right side, we see a typical LED strips with the RGB LED and additionally a white LED. And with a DALI gateway, we can control here the ballast by using this RGB principle, or we can use also here the HSV color space. There's another possibility, which is also popular on the market, but here we have three other parameters. One is the so-called hue. This is like, for example, here a cone. So here on this wheel, we have 360 degrees between 0 and 360. And when we have a value of 0 degrees, then we have the color red, 120 degrees, then we have the color green, and 240 degrees is the color blue. So the first parameter is the color. The second one is the saturation. The saturation gives how many white color we mix. So when we have here saturation of 100%, then we have full brightness. And when we mix here additionally white color, then we have more pastel. So this is a value between 0 and 100%. And the third parameter is here the value of the brightness. So when we give full brightness, 100%, then we have the full color. And when we reduce the brightness here to 0, then we have black. So it depends on you which kind of principle you want to use, RGB or HSV. The DALI gateway can offer both possibilities. And of course, there's a kind of transformation between RGB and HSV. By mathematical calculation done in the gateway, we can change here also between HSV and RGB. So in this color control can be used for each group and ballast, of course. We can dim the color by using 1 byte objects between 0 and 100%, and we can also set values. So we are really here flexible. Additionally, we can use the color control also in scenes and sequences. And we have both possibilities to use the RGB. And if you want to use HSV, then you get the group objects to link the corresponding group addresses. But internally, the DALI gateway converts it into RGB, because on the market, there are most common used are RGB ballast. And for controlling the colors, how to control it via KNX telegrams, of course, you can use typically 4-bit for dimming the color between 0 and 100%. Like here on the right side, you have a standard control element with 1 rocker. You dim here the brightness from 0 to 100% for red, a second rocker green, a second rocker blue, and the third one, for example, for the brightness. So we can use each standard control element for color control with our DALI gateway. Or what is more comfortable, to use the combined 3-byte group object, RGB HSV, according to the data point type color RGB 232-600. Or if you want to use the RGB W or HSV W, then you can use the so-called combined 6-byte group object according to this data point type 251-600. So the DALI gateway is able to be controlled by any kind of group address and data point you want. It depends maybe on your panel, on your app, or what you have, or your control element. And by the way, on the right side, you can see here a typical ballast from the device type 8, RGBW. The device has 1 address, but 4 outputs, or so-called 4 channels, red, green, blue, and white, and 1 common. So then let's come to the so-called function sequences. Sequences, what is it? It's a nice feature for lighting effects, made very easy. So we need no additional logic in a controller external or something. So a sequence is a series of brightness values or color gradients, like we have it in shops, in restaurants, in a hotel, for example, or especially in sauna or swimming pool, where the color should change automatically, wellness areas, entertainment, or also for medical applications, like for our HCL, for light therapy, or for mood enhancer, when we use tunable light in a sequence, for example. And of course, for Humancentric Lighting, to simulate the daylight with a sequence. So, and many, many more. So like we see it, for example, here on pictures on the right side. So then let's go a little bit in details of the sequence. So it is a nice, it's a new function in the application version 2.0. And by using a sequence, we can call up to other color values like RGB, HSV, or color temperatures, warm white, cold white, and of course also brightness values after the other. So we have maximum 10 steps. And then it starts with step number 1, step number 2, and so on. Total, we have 11 steps, 10 plus 1. The last step is the end step. So when the sequence stops, you can say, please do these additional end steps. So in each step can be applied to a ballast, to a group, to a scene, or to the complete output. Like we have it here on the right side. This is a screenshot of the ETS. You see here the maximum 4 sequences per output. And then you can enter the maximum number of steps between 2 and 10. 10 is the maximum. And the number of cycles. When you enter here 0, then we have here no limitation. So then the sequence runs endless until you send here a group address with the value 0 to stop the sequence. So with a 1, the sequence can start it, and with a 0, it stops. Or you enter here maybe 5, and then you have here 5 cycles. And then we can define a reaction when we stop the sequence. Should it do an end step, like at the end, for example, switch the light complete off, or do the complete cycle and then stop with the last value. So in here you see how easy it is to create such a sequence. You enter here the number of the steps, like 10, and then you can select what should happen in the step number 1. A group, yes, I want to control group number 6. Go to 97% brightness, color type, RGB, and maybe make here a dark red color and the value of white 255. The dimming speed 5 seconds. So after 5 seconds, he reached exactly these values, and then he's waiting 10 seconds. And after 10 seconds, he calls the next step, which is a scene. So then he calls the scene number 3, and 200 seconds later, he starts the step number 3 with ballast number 36, 77%, and he goes to 3000 kelvins. And again, 40 seconds later, go to the ballast number 5, goes to this color. So when you click exactly on this field color, then it pops up here, this color picker. And in the color picker, you can enter here the value like RGB from 0 to 155, red, green, blue, or in HSV. So what do you prefer? Like here, the degrees, and here the saturation and the brightness. So it's very easy really to create here these sequences inside the ETS. So typical applications of such a sequence is like for human-centric lighting. So you simulate, for example, the daylight with a sequence. So make here the 10 steps and 10 steps with a step duration of, for example, 1 hour. And then you call every hour here another color temperature value. Start with 3000, 3500, 1 hour later 4000, up to 6000, and then go down again. Typical application of a sequencer. Or like here for color control here with color gradients, like in a sauna, or here, for example, in a spa, that we create here a sequence, and every minute another color here is now called endless. So only when we stop at the end, send the value 0, and then the sequence stops, and we'll see at the end, group number 5 is the light switched completely off. This is our additional end step we can define. So very nice feature here, the sequences. Then let's come to the so-called load shedding. So with load shedding, we want to avoid load peaks. So, and of course, we want to reduce the costs, and also we want to optimize our energy. So when we want to do this kind of load shedding or load control, we need a so-called control master, which offers us this feature of load shedding. It can be, for example, our energy actuator SAS, or our KNX energy analyzer QAS. This is a device which sums up the power of all KNX meters, and then when he reach a limit, then he send out so-called load shedding stages to switch off some outputs. And on the right side, you can see the screenshot of the KNX Energy Analyzer QAS 161. So we have given numerous webinars and trainings about this device, and you will find everything in our training qualification database about this device, and of course about all other KNX devices. So, okay, this is our master, the energy analyzer, and what we have now integrated is the DALI gateway. So the DALI gateway is now able to listen to the energy analyzer and reacts when this, for example, threshold of the power values is now exceeded. So very important, we don't want to switch off the light. So the only thing what we do, we set a limitation of the maximum brightness. So depending on the load shedding stages, to save also energy by using the DALI gateway. And here you can see a typical example of such a load shedding. Our target is to prevent load peaks and of course to reduce our cost. So in the middle, we have our master, our load control master. This is here the KNX Energy Analyzer QoS. He sums up the power values of all our KNX energy meters. This can be, for example, our energy module, the energy actuator, this is a switch actuator with an energy meter built inside. Or if you have, for example, ABB energy EQmatic meter, via the meter interface ZSS, it's the optical interface, we get all meter values here on KNX. Or another possibility is to use our new energy actuator with switch actuator here with energy function. So all these devices send here the power values to the energy analyzer, and he sums up all the values. And now when he reach here a threshold, and then he sent out shedding stages according to this object data point type 236001. This is a 8-bit or 1 byte telegram with the value or the number of the shedding stage. So he starts with shedding stage 1, send it here on KNX, and the devices which were linked with this group address and has this function of load shedding, then you can say, okay, shedding stage number 1, switch off, for example. So, but what happens? The load is still exceeded our threshold, and then the energy master, the energy analyzer send here the next shedding stage, number 2, to KNX. Here, for example, to the DALI gateway, and the DALI gateway, some of the ballasts are now linked, or groups are linked here with the group with this function, and then the maximum brightness here is limited of the devices. You see, if the light is now 100% on, it goes now to 50%. Or if the light is 30%, then of course it remains at 30%. The only thing is that we have here a higher priority when we use this load shedding function in our DALI gateways with the limitation of the brightness. Additionally, this energy analyzer QoS is also able to send 1-bit telegrams with the load shedding stage. That also third-party devices, not only ABB, can be also integrated here in this load shedding function. So he sent up to 8 1-bit telegrams. Good, so far this is a load shedding function to save your energy and to reduce energy costs by using here the DALI gateway and our master. So then let's come to another nice feature, so-called operating duration. Operating duration means we can get the information how long a group or a ballast remains switched on. So it helps us, for example, to create here some plans for maintenance or for replacing of some lamps, because over the time the lamps, they lost their luminosity, and in some building like in hospital it's a requirement to replace every, I don't know how many thousand of hours, operating hours, to replace the lamps. So, but when you have a look on our ballast, the ballast is possible that some ballast on the market can count operating hours, but counting the operating hours in a ballast is not a mandatory function according to the DALI standard. So, it can, but it must not support it by the ballast. So, but we want to get the operating hour, then we count the operating hour in our DALI gateway. So when we say only a ballast is switched on when the device gets the information on, and we have no lamp failure, no ballast failure, and the brightness value is greater than 0%. And then we believe that the ballast or the lamp is really switched on. So by counting this hours here, the time in our DALI gateway, we get really here the information, because the function is not mandatory in the DALI ballast. So, and then we get this operating duration per group. We get it per ballast. So per ballast, we have a separate group objects, the value of the operating duration, and we get also a 1-bit alarm function. So when we reach this threshold, the group objects of my ballast number 5 send a 1-bit alarm message to my panel or to my control touch, and I receive here a push notification on my mobile phone, for example. Additionally, we get it also addressed. Addressed means that we have a 3-byte group object, and in this 3 byte, we have the operating duration and we have the number of the group or the number of the ballast. This is for example, more easy when you have a visualization, then you have to link only one group address per output to your system. And we don't say operating hours because we say operating duration, because we get the information in hours or seconds. It depends what you set in the ETS parameterization. So, and of course, we can also change the operating duration in the DALI gateway by sending a command via KNX telegram or the IBUS tool, because after replacing a lamp, you can set it to 0 or maybe 200 or 2000. We are really here flexible. And if the alarm limit per group or per ballast is reached, then the gateway sends here a value 1 on KNX to trigger the alarm message. Good, then let's come to the so-called standby switch off function. At first, let's have a look here on our DALI ballast. A typical DALI ballast is permanently connected to the supply voltage. Like we see here, voltage plus minus, or here the 230 volt, so AC. So permanently, what does it mean? When the device is switched off in the so-called standby mode, it has a power loss of about 0.1 or 0.2 watts. Per device, it is of course a very slow value, but if you have 10,000 of ballasts in a building, then you have really here maybe 1,000 of watts power loss. And according to the energy efficiency and or to save energy, we have here this standby function to save the energy, because when all devices, all ballasts on one DALI output are switched off, it's possible here to switch off the supply voltage of these devices. So then let's have a look here on this function. So at first, the DALI standby switch off function can be used per output. And only when all devices are in the standby mode or switched off per output, then it's possible to activate here the standby switch off function. This happens automatically in the DALI gateway. So, and we can switch off the supply voltage of this DALI ballast by using here a standard switch actuator, or if you have a higher load, for example, by using here an installation contactor with 40 amps or 63 amps, also possible. So very important, if this function is now active, then the message ballast fault is suppressed. So very important. So we get no ballast failure message on KNX. And of course, DALI emergency converters are not integrated in the standby switch off function because they should be connected permanently to this 200 to the supply voltage. So additionally, the ballast must also support here this individual DALI power on level brightness. This must be possible in the ballast. So then when we have here a look on the standby function, you will see here on the right side, some lights are here on, then the switch off function is not activated. Only if all lights are here off on a complete output, then the DALI gateway activates after adjustable time, the so-called standby function automatically, it's activated. Then he sends the value 0 on KNX to switch off here the supply voltage of this ballast. And then we get no ballast fault message. So what happens when someone enters the building or the room, open office or staircase? So the presence detector or a control element sends the value 1 on KNX. The DALI gateway deactivates the standby function, switch on here the switch actuator, the DALI ballast gets now energy, they start up, and after 1 second they should be ready. And the DALI gateway waits a time between 1 and 10 seconds, and then he sent the command on DALI to switch on here the light. So only the first time we have here a short time delay of minimum 1 second that here the ballast are now ready for operation. Good, then let's come to our DALI let's come to the ABB IBUS tool, the software for diagnostic and for testing our KNX devices. So we have also here additional function. At first, the ABB IBUS tool is needed for the parameterization of the DALI gateway for doing the individual addresses, the assignment to the groups and so on. So now what we have done are some new parameters. Like for example, here in the overview, we have that parameter that the brightness level of unselected devices are not changed. It helps you, for example, if you go to a building which is in operation and you select a device for testing or for replacing, that the other devices remain unchanged. Or what is also new, that we can make a step-by-step monitoring. So now when you click here on one device, then exactly this device is now monitored and you cannot change its address. So now when you do commissioning, of the devices, you change the address, links to groups, and then you can click it here step by step, and then you know exactly what you have done today. Or here for RGB gives us also some information here about the parameterization in the ETS. Have we parameterized it in the ETS as a tunable white color control device, and the feedback of the ballast, or here also the feedback, which device is this? Is this a RGB with 4 channels, or for color temperature, the operating hours, and some more we can do here with our DALI gateway. So further information about our devices, you will find it on our webpage, abb.com/KNX. Then you can go to products and downloads, light control, DALI. We have also extensive training content on our training and qualification database. There's also a link here from our homepage where you can find a lot of video sessions, learnings, tutorials, presentations about all our devices, and special about the DALI Gateway Premium with the standby, switch off, color control, and so on. And of course, you will find also the information here on our YouTube channel. Good, so far I'm at the end of my presentation, and I want to thank you for your listening. At 11 o'clock this morning, AM, Central Europe summertime, my colleague Thorsten Reibel will present the ABB IBUS tool in details to you. We're looking forward to seeing you on our booth or in the chat. Goodbye and have fun on the experience. Goodbye.